Hello everyone, and welcome to this tutorial which is on the June 2019 Higher Paper 2, which is a calculator paper. Now it's important to note whether it's a calculator paper or non-calculator paper, you must always show your working out. So whatever calculation you insert into your calculator, you must write it down. If your calculator does not have a pi button, then take the value of pi to be 3.142 unless the question instructs otherwise. So let's have a look at question 1. Well, question 1 wants us to solve 14n is greater than 11n add 6. Now what's important to note is the method we use to solve inequalities is exactly the same as what we use to solve equations. Subtracting 11n from 14n gives me 3n, and subtracting 11n from 11n add 6 gives me 6. Now 3n is greater than 6, so I simply divide by 3 and it gives me n is greater than 2. Now the next question states that on the number line below we need to show the set of values for x for which minus 2 is less than x plus 3, which is less than or equal to 4. Now just like solving an equation, you need to get the x term on its own. So the method is still the same. The only difference is there's 3 parts to this inequality. To get the x term on its own, we subtract 3. But we simply subtract 3 from each part. So minus 2 subtract 3 is our minus 5, x plus 3 subtract our 3 is our x, and 4 subtract 3 is our 1. So therefore the inequality is minus 5 less than x less than or equal to 1. Now putting this on a number line, let's identify minus 5 first. Notice how I've kept this hollow because it's less than x and it does not include x. Now let's indicate our 1. Notice how I've filled the circle in because it's equal to 1. So the range of solutions for x are in between minus 5 and 1, not including minus 5, but including 1. Question 2 says, on the grid below we're asked to draw y equals 2x minus 3 for all values of x from minus 2 to 4. Now there's a few different ways to do this. For me, I'm going to draw a table. Now it states that the x values have to go from minus 2 all the way to 4. Once we've identified our x values, I'm simply going to substitute into my function. So if x is minus 2, 2 times our minus 2 is minus 4, subtract our 3 gives me minus 7. When x is minus 1, 2 times our minus 1 is minus 2, subtract our 3 is minus 5. And you simply work out all the y coordinates given our x coordinates. Now we have our coordinates, we simply plot. So plotting minus 2 and minus 7 is indicated here. Plotting minus 1 and minus 5 is indicated here. Plotting 0 and minus 3 is indicated here, so on and so forth. You know you've done it right because the function y equals 2x minus 3 is a straight line. So when we join all our points, you can see we've made our straight line. Question 3 states that Hannah is planning a trip for 195 students. Now she asks a sample of 30 students where they would like to go, and each student chooses one place. Now the table shows information about her results. You can see 10 students wanted to go to a theme park, 5 students wanted to go to the theatre, 8 students said the sports centre, and 7 students said the seaside. Now we're asked to work out how many of the 195 students you think will want to go to the theme park. The topic of maths that we're looking at here is stratified sampling. And stratified sampling is used to select a sample that is representative of the different groups or strata. Each group will be proportional to the number of items in that group. The great thing is there is a formula. So to find out the number selected from each group, it's simply the group size over the population we have multiplied by the sample size. So to work out how many students of the 195 we think will go to the theme park, it's simply 10 because that's how many people were selected, because that's how many people said they wanted to go to the theme park, over the 30 because that's the total she has, multiplied by the 195 because we need to find out of that 195 how many will want to go to the theme park. This gives me an answer of 65. Now we're asked to state any assumptions we've made and explain how might this affect our answer. Well, remember, stratified sampling assumes that each group is proportional to the number of items in that group. So the sample is representative of the whole population. Otherwise, the answer would be incorrect. Question 4 states a container is in the shape of a cuboid. The container is 2/3 full of water. Now a cup holds 275 milliliters of water, and we're asked what is the greatest number of cups that can be completely filled with water from the container. Well, first of all, let's find the volume of our cuboid. We know the volume of our cuboid is 30 multiplied by 6 multiplied by 19, which gives me 3,420 centimeters cubed. Now we know the volume of our cuboid is 2/3 water. So the volume of water in our cuboid is 2/3 times our 3,420, which is 2,280 centimeters cubed. Now remember our conversions. 1 litre is equivalent to 1,000 centimeters cubed. 1 litre is 1,000 milliliters, so that means we know it's exactly the same as 1,000 centimeters cubed. Given that we know 275 milliliters of water is in a cup, we need to convert this into centimeters cubed. So that means 275 milliliters is exactly the same as 275 centimeters cubed. Now, given we know this, we can find out how many cups can be completely filled with water by simply dividing. So the greatest number of cups to fill the container is the volume of water, 2,280, divided by our 275, which is the volume of our cup. This gives me 8 cups. Question 5 states ABC is a right-angled triangle. We're asked to find the length of AB, giving our answer to 2 decimal places. Now, whenever you're given a right-angled triangle with a labeled angle and length, you know we're looking at trigonometry. So remember, SO, CA, TOA. SO indicates sin theta is opposite over hypotenuse. CA indicates cos theta is adjacent over hypotenuse. And TOA indicates tan theta is equal to opposite over adjacent. So let's label what we know. Well, the question wants us to calculate AB. So I know, given my angle is here, this is the opposite. I know this length is labelled, so this is my hypotenuse. I'm not given any information here, so I'm not going to label it. Therefore, the trig ratio I'm using, which uses opposite and hypotenuse, must be sin. So I know sin theta is equal to opposite over hypotenuse. Now let's substitute what we know. Well, we know the angle is 38, the opposite we don't know, but we know the hypotenuse is 16. Now rearranging to work out the opposite, it's simply sin 38 multiplied by our 16. This gives me the opposite length to be 9.850, so on and so forth. Now, given the question wanted me to round my answer to 2 decimal places, this means my answer is 9.85 to 2 decimal places. Question 6 says Sally used her calculator to work out a value of a number y. The answer on a calculator began with an 8.3. We're asked to complete the error interval for y. Well, if you can imagine a calculator screen showing 8.3, this must be the absolute lowest value. So therefore, the lowest value in our error interval for y must be 8.3. Now let's have a look at the highest value in our error interval. Well, if you can imagine on a calculator screen, for it to be 8.3999, and those 9s going on forever. Now, to illustrate this on our error interval, we must state that it's less than 8.4. That means it doesn't include the 8.4, and you can see it satisfies the calculator display of being 8.39 recurring. Question 7 states that £360 is shared between Abby, Ben, Chloe and Denise. The ratio of the amount Abby gets to the amount Ben gets is 2 to 7. Chloe and Denise each get 1.5 times the amount Abby gets, and we're asked to work out the amount of money that Ben gets. Our top tip is to basically do one sentence at a time. So, starting here, we know the ratio of Abby to Ben to Chloe to Denise is given here. Now we do know the ratio of Abby to Ben is 2 to 7. We don't know Chloe and Denise just yet. But we do know Chloe and Denise each get 1.5 times the amount Abby gets. So if we multiply 2 by 1.5, we know Chloe gets 3 parts and Denise gets 3 parts. Now from here, we know the total parts is the total amount of money. So that means 15 parts is £360. So 1 part must be £24. The question wants us to work out how much Ben receives. Ben gets 7 parts. So if 1 part is £24, we know Ben must receive 7 times 24, which is £168. Question 8a wants us to write 0.00562 in standard form, and B wants us to write 1.452 times 10 to the 3 as an ordinary number. Now what's important to note with standard form is the notation. A times 10 to the B, where A is a number between 1 and 10, including 1, and B is the power. And if B is positive, then we know the number is a very large number, and if B is negative, then we know the number is very small. So let's have a look at 8a. Well, we know straight away that we're going to have a negative power of B. Looking at the digits 5, 6, and 2, it must be 5.62, multiplied by 10 to the power of minus 3. A nice little trick to identify the integer value here for small numbers with standard form is to count the number of zeros. So our answer is 5.62 times 10 to the minus 3. Now 1.452 times 10 to the 3 is exactly the same as 1.452 times 1,000. So this is 1,452. Question 9 states that the circumference of circle B is 90% the circumference of circle A. And we're asked to find the ratio of the area of circle A to the area of circle B. So let's identify what we have from our first sentence. Well, straight away we know that A and B are similar. Looking at the circumference of A to the circumference of B, we know that the scale factor must be 0.9 because the circumference of circle B is 90% the circumference of circle A. So the multiplier of 90% is 0.9. Next, we're looking at area. Now remember the relationship with scale factor and area. This would be our scale factor squared. So it would be our 0.9 squared, which gives me the scale factor of the area of circle A to the area of circle B to be 0.81. So therefore, the ratio of the area of the circles is 1 to 0.81. Now this is right, but it doesn't quite look right. So I'm just going to multiply both numbers by 100. This would give me 100 to 81. Now the second part says square E has the side lengths of E centimeters and square F has the side length of F centimeters. Now the area of square E is 44% greater than the area of square F. And we're asked to work out the ratio of E to F. Now just like before, we can see that these two squares are similar. So let's compare the area of square F to the area of square E. Well, remember, given that we know the area of square E is 44% greater than the area of square F, and we're talking about area, that means the scale factor squared is equal to 1.44, because the multiplier for 40% greater is 1.44. Because it's area, this is the scale factor squared. So in order for me to find the length of square F to the length of square E, I need to find the scale factor. To find the scale factor, we simply square root the 1.44, which gives me the scale factor to be 1.2. So now I know the ratio of length of the squares is simply 1 to 1.12. I'm going to rewrite this as 10 to 12 and then simplify to give me 5 to 6. But remember, this is the ratio F to E. The question wanted me to find the ratio of E to F. So therefore, the ratio of E to F is 6 to 5. Question 10 says Mary travels to work by train every day. The probability that her train will be late on any day is 0.15. we're asked to complete the probability tree diagram for Thursday and Friday. So, if the probability that the train is late on Thursday is 0.15, then we know the sum of the probabilities of this branch has to be 1, so that means we know the probability of not late on the Thursday is 0.85. Now, we know the probability that her train will be late on any day is 0.15. So that means on the Friday, the probability of it being late is still 0.15, and not late is 0.85. Even if on the Thursday the train wasn't late, the probability of it being late on the Friday is still 0.15. So the probability of it not being late is 0.85. Now part B states that we need to work out the probability that our train will be late on at least one of those 2 days. Now to work this out, we need to know what this means when it says late on at least one of these 2 days. Well, it means the probability of a late and a late, or not late and a late, or a late and a not late. Because you can see these are the different types of outcomes we can get where we can have at least one late. Working this out, well, the probability of a late and, which is times, a late is 0.15 times 0.15. Probability of not late and then late is 0.85 times our 0.15. And the probability of late and then not late is 0.15 times our 0.85. Working this out identifies the probability of being late at least one of the 2 days is 0.2775. Now there is an alternative way for you to work this out, which is a little bit quicker. Now the probability of her being late on at least one of these 2 days means it's 1 subtract the probability of her being not late on both days, because these are mutually exclusive events. So, the probability of not being late and not being late is 0.85 times our 0.85. 1 subtract that confirms the probability is 0.2775. So remember, in maths there's usually more than one way to get a solution. But what is important is that you show the correct working out. Question 11 states that the group frequency table gives information about the times in minutes that 80 office workers take to get to work. So, looking at the table, 5 people said it took them between 0 and 20 minutes, including 20 minutes. 30 people said it took them between 20 and 40 minutes, including 40 minutes, so on and so forth. The question wants us to complete the cumulative frequency table. And remember, cumulative means we're adding up as we go along, and you can see that in the class intervals. So we need to sum the frequencies between 0 and 20. So you can see the frequencies between 0 and 20 are 5. The frequencies between 0 and 40, well, it would be the sum of the 5 and the 30, which is 35. Now the sum of frequencies between 0 and 60 would be the 5 add the 30 add the 20, and so on and so forth. So you're basically adding up the frequencies as you go along. The great thing about this type of question is you know you've got it right, as the end value in your cumulative frequency table will always match the value given in the exam. Now the question wants us to draw the cumulative frequency on the grid provided. Now it's important to note that you must always plot the upper value of our class interval, because this is the maximum that it could potentially be. So we plot our 20 minutes against our cumulative frequency of 5. We plot our 40 minutes against our cumulative frequency of 35, and so on and so forth. Once we've plotted, then we simply draw our curve. It's very important in the higher exam paper that you pay careful attention to your axes and plot as accurately as you can. Now part C states that we need to use our graph to find the estimate for the percentage of these office workers who take more than 90 minutes to get to work. So we need to look at 90 minutes first using our x-axis and reading across, and you can see we have a value of 76. But we're interested in more than 90 minutes. So that means we need the value greater than this. So that means the number of people more than 90 minutes must be 4 people. Because the question wants us to work out the percentage, This is simply 4 divided by our 80 multiplied by our 100, which gives me our 5%. Question 12 shows OAB is a sector of a circle with centre O and a radius of 7 centimeters. It states that the area of the sector is 40 centimeters squared, and we're asked to calculate the perimeter of the sector, giving our answer to 3 significant figures. Now what's important to note are the formulas associated with sectors. Remember, to work out the area of the sector, it's the fraction theta over 360 multiplied by the formula for the area of the circle. So theta over 360 times pi r squared, where theta is the angle of our sector. To work out the length arc, it's the fraction of our circle multiplied by the formula for the circumference of a circle, which is 2 pi r. So now we've recapped, let's substitute what we know. Well, we know to work out the area of the sector, it's theta over 360 pi r squared. Substituting the area to be 40, which was given in the question. I don't know my angle, but I do know it's over 360 times pi times our radius squared. So therefore, I've formed an equation so I can find out theta. Simplifying a little bit more gives me 49 theta over 360 pi. Now remember, I need to find theta, so all I'm going to do is divide by 49 over 360 pi. This will give me theta. Because it's a calculator paper, I can just substitute this into my calculator, verifying that theta is 93.5 degrees. Now I know theta is 93.5 degrees, I can work out the arc length. Well, to work out the length, we know the arc length is theta over 360 multiplied by 2 pi r. We know theta is 93.5 over 360 times 2 times pi times the radius, which gives me the arc length to be 11.4 centimeters. Therefore, the total perimeter of the sector is 7, add 7, add our 11.4, which gives us 25.4 centimeters, correct to 3 significant figures. Looking at question 13, it says show that 6 add all of this, which is x plus 5, divided by x squared plus 3x minus 10 over the x minus 1, simplifies to ax minus b over cx minus d, where a, b, and c and d are integers. Now, with this type of question, it does look pretty scary, but all you have to do is just do one little bit at a time. Well, first of all, let's look at what's inside these square brackets first. Well, you can see we are dividing by a fraction. So looking at our fraction, I think we can simplify this a little bit more by factorizing that quadratic. So just looking at our algebraic fraction, we have x squared plus 3x minus 10 over our x minus 1. Now I'm going to factorize this numerator. So I can see x squared plus 3x minus 10 is exactly the same as x plus 5x minus 2 over our x minus 1. Now I'm going to pop that back into the original question. So I have 6 add my x plus 5 divided by the quadratic factorized over the x minus 1. Now I'm still dividing my fractions. And remember, whenever you divide fractions, it's this particular rule. A over b divided by c over d is exactly the same as a over b times the reciprocal of c over d, which is d over c. So when I'm dividing by this algebraic fraction, it's clear to see this is exactly the same as multiplying by its reciprocal. Now I'm going to simplify this a little bit more so the expression is a little easier. This gives me 6 plus the x plus 5 multiplied by x minus 1 over the x plus 5 over the x minus 2. Now I can see I have a factor in my numerator and denominator. So I'm simply going to cancel these down, thus leaving me with 6 plus x minus 1 over our x minus 2. So we're nearly there. Now what we have to do is look at our 6, because in this part of our fraction we have a denominator of x minus 2. So let's make the 6 have a denominator of x minus 2. To do this, I simply multiply the 6 by x minus 2 over x minus 2. Adding our x minus 1 over x minus 2 gives me the sum of these two fractions. Now, because my denominator is the same, I can write it as a single fraction. So x bracket x minus 2 add x minus 1. Well, from here, I can simply expand and simplify. Multiplying out, I have 6x minus our 12 add our x minus 1, still over that x minus 2. Now you can see we're going to simplify, and it will be to this form. So 6x add our x gives me my 7x, minus 12 subtract our 1 gives me minus 13, and it's still over our x minus 2. So notice how we've written it in the form of ax minus b over cx minus d, where a, b, c, and d are our integers. Question 14 states a car moves from rest. The graph gives information about the speed, v meters per second, of the car t seconds after it starts to move. So as you can see, the x-axis shows the time in seconds, and the y-axis shows the speed in meters per second. The question wants us to calculate an estimate of the gradient of the graph at t equals 15 seconds. So what's important to note is this word gradient, and how do we find it? Well, the gradient is simply the difference in y-coordinates over the difference in x-coordinates. But how do we find this? Well, looking at time 15 seconds, we need to draw a tangent at this particular time. So then we can identify the coordinates. The tangent can be as long or as short as you want, but as long as the tangent touches at the point t equals 15 seconds, like I've done here. Now, I've deliberately limited my line segment to these coordinates, just because it's easy to extract the coordinates. So my first coordinate is here, and my second coordinate would be here. Pulling out these coordinates, I've identified this coordinate to be 12.516, and this coordinate to be 7.520. You can use any line segment you want, as long as it's a tangent at t equals 15 seconds. Now from here, I'm going to label accordingly. So this is my x1 and y1, and this is my x2 and y2. Substituting this into my formula to work out the gradient, you can see the gradient would simply be 20 subtract our 16 over the 17.5 subtract our 12.5. This gives me an answer of 0.8. Like I said, as long as you've drawn a line segment which is a tangent to the point t equals 15 seconds, you can use any two coordinates, and the mark scheme accepts any values between 0.6 and 1.0. Now, the second part says, describe what your answer to part 1 represents. Well, because we're looking at a rate of change of speed, this means the gradient represents acceleration. Question 14 says work out an estimate for the distance the car travels in the first 20 seconds of its journey. We're asked to use 4 strips of equal width. Well, first things first, remember we have a speed time graph. So therefore, the distance is the area under the curve. So the question is asking us to work out the area of the curve between 0 and 20 seconds using 4 equal strips. So let's divide them equally. Well, you can see here are our 4 equal strips. And now I'm going to create some simple polygons so I can work out the area. Now what you might notice is I have 3 trapeziums and a triangle. So remember the formula for the area of a trapezium. It's a half times a plus b times our height, where the a and the b are our parallel lengths, and the height is always perpendicular to the base. So let's substitute what we know, starting with area 1. Here is my trapezium, and you can see this length here is parallel to this one. Working this out, it would simply be a half times the 17.5 add the 20 multiplied by our perpendicular height. This would give me an area of 93.75. But remember, this represents the distance, so I've labelled it as meters. Looking at area 2, we have a trapezium. So we're looking at this parallel length and this one with the perpendicular height here. Well, it's a half times, I'm reading this to be about 12. This is 17.5, and we know our height is 5. Working this out gives me 73.75, but remember the units would be meters because it's distance. Looking at area 3, same again, we have trapezium. So it would be this parallel length and this one with the perpendicular height. Working this out, it would be a half times, I'm reading approximately 4, add the 12, and then we have a perpendicular height of 5. So this gives me 40 meters. Lastly, I have a triangle, so working out the area of the triangle would simply be a half times the base times the height, which gives me 10 meters. So therefore, the total distance travelled would be the sum of all our areas, which for me is 217.5 meters. As it's an estimate, the examiner will accept any distance between 215 and 225 meters from correct working out from our 4 strips. Question 15 wants us to make m the subject of our formula, where f equals 3m plus 4 over our m minus 1. Because we have 2 terms including the letter m, it's important that we bring these m terms together. So let's start by multiplying by m minus 1. So multiplying f by m minus 1 eliminates that fraction. So I have f bracket m minus 1 equals 3m plus 4. Now I'm simply going to expand to give me fm subtract f equals 3m add 4. Now, just like I said, because we want to make m the subject, it's important to bring all those m terms together and all the other terms on another side. So I'm going to subtract 3m from both sides and then add f. This would give me fm subtract 3m equals 4 add f. So as you can see, I now have all my m terms on one side and all the other terms on the other side. Now from here, I can simply factorize. This gives me m bracket f minus 3 is equal to 4 add f. Because I have my single value of m, I can simply divide by f minus 3. Therefore, I've made m the subject, which is 4 plus f over f minus 3. Question 16 states the straight line L has the equation 3y equals 4x add 7. And it states the point A has the coordinates 3 minus 5. It asks us to find an equation of the straight line that is perpendicular to L and passes through the point A. So first things first, we know we're asked to find the equation of a straight line. Now the general template for a straight line is y equals mx plus c, where m is the gradient and c is the intercept on the y-axis. So let's look at equation L first. Well, equation L is 3y equals 4x add 7. Now writing it in the form y equals mx plus c, I'm simply going to divide everything by 3, giving me y equals 4 over 3x plus 7 over 3. This is important because we're able to identify the gradient quite quickly. So we know the gradient of our line L is 4 over 3. Now, remember the relationship between perpendicular gradients. Well, if we have 2 perpendicular lines, this is the relationship between their gradients. Gradient 1 is the negative reciprocal of the second gradient. So if we know the gradient of line L is 4/3, we immediately know the gradient of the perpendicular line to be minus 3 over 4, because it's the negative reciprocal of this gradient. So remember, we're asked to find the equation of a line. And the equation of any line is y equals mx plus c, and we know the gradient of our perpendicular line is minus 3 over 4. So let's see if we can find c. Well, we know our perpendicular line goes through the point 3 minus 5. So we can substitute our x value for 3 and our y value for minus 5 into our equation so far, and then we can find c. Substituting, we have minus 5 is equal to minus 3 over 4 multiplied by the x-coordinate, which is 3, and then obviously we add c. This then gives me minus 5 is equal to minus 9 over 4 add c, so we can clearly work c to be minus 11 over 4. So now we have our equation of our straight line, which is y equals minus 3 over 4x subtract our 11 over 4. Question 17 says there are some small cubes and some large cubes in a bag. The cubes are red or the cubes are yellow. The ratio of the number of small cubes to the number of large cubes is 4:7, and the ratio of the number of red cubes to the number of yellow cubes is 3:5. we're asked to explain why the least possible number of cubes in the bag is 88. Well, with this type of question, it's important to look at one sentence at a time. So, starting with this ratio here, we know the ratio of the number of small cubes to large cubes is 4 to 7, and this is in its simplified form. So, the smallest possible number for large and small cubes is 11, given the ratio of 4 to 7, because it's the sum of 4 and 7. Now, the ratio of red cubes to yellow cubes is in the ratio of 3 to 5. This again is in its simplest form. So, the smallest possible number for red and yellow cubes is 8, which is the sum of 3 and 5. That means the lowest common multiple of 11 and 8 is our 88. Now the next question says all the small cubes are yellow. So we're asked to work out the least possible number of large yellow cubes in the bag. Well, first things first, we know the ratio of small to large is 4 to 7. We also know that the smallest possible number of cubes in the bag is 88. So 4 add 7 is 11, so to make the total of 88, I simply multiply by 8, giving me the equivalent ratio of 32 to 56, because 4 times 8 is 32, and 7 times 8 is 56. This gives me as the smallest possible sum of cubes, which is 88. Now let's have a look at red to yellow. Well, the ratio of red to yellow is 3 to 5, but remember the smallest number of cubes is 88. So we need to multiply so we have a total of 88. 3 add 5 is 8, so I need to multiply each number by 11. 3 times 11 is 33, and 5 times 11 is 55. And you can see I've got a sum of 88 cubes. Now, given that all the small cubes are yellow, we know the 32 cubes here are yellow. Given we're asked to find the least possible number of yellow cubes, we know all the small cubes are yellow. Now we know there's 55 cubes in total, and 32 are all small. So to work out the large, it's simply 55 subtract our 32. This would give me 23 large yellow cubes. Question 18 shows a circle with the points A, B, C, and D. It states that CDE is a straight line. It also states that BA is equal in length to BD, and it also states that CB is equal in length to CD. It shows us that the angle ABD is 40 degrees. And we're asked to work out the angle ADE, and we have to show each stage of working out. With this type of question, it's important to label what you know. So you can see we have two isosceles triangles. So let's label our angles that we can work out, starting with angle BAD. Because we have a triangle and it's isosceles, we know these two base angles will be the same. So to work it out, it's simply 180, subtract our 40, divide by 2. This would give me angle BAD to be 70 degrees. It'll also give me angle BDA to be 70 degrees also, because we know base angles of an isosceles triangle are the same. Now we know these base angles, you may have also spotted we have to use circle theorems in this question. So hopefully you could have spotted that cyclic quadrilateral. Now we know angle BAD is 70 degrees. We can work out angle BCD because we know the opposite angles in a cyclic quadrilateral sum to 180 degrees. So 180 subtract our 70 degrees gives me angle BCD to be 110 degrees. Now we know angle BCD to be 110 degrees, we can focus on this isosceles triangle. We can work out angle BDC to be 180 subtract 110 divided by 2, which is 35, and this will be the same angle as angle DBC, as we know base angles of an isosceles triangle are the same. Now remember, the question stated that CDE is a straight line. So we've just worked out this angle to be 35, this angle to be 70, and we're asked to work out angle ADE. Because we know angles on a straight line sum to 180, This means it's 180 subtract our 70 subtract our 35 will give us angle ADE. Thus, my final answer for angle ADE is 75 degrees, because we know angles on a straight line sum to 180 degrees. Question 19 shows a triangular prism. It states that the base ABCD of the prism is a square of length 15 centimeters. It also states that ABC and CBE are right angles, and it also shows that angle EAB is 35 degrees. It states that M is a point on the line DA such that the ratio is D to M to A is 2 to 3. We're asked to calculate the size of the angle between EM and the base of the prism, giving our answer to one decimal place. So like before, always do one sentence at a time and label what you know. The great thing is, these sentences have already been labeled on our diagram. So let's look at this line. M is a point on DA such that DM to MA is in the ratio of 2 to 3. I'm going to label M approximately here, because I know we've got a ratio of 2 to 3. Now 15 centimeters needs to be divided according to this ratio. So 15 divided by 5 is 3, multiplied by the 2 means DM is 6 centimeters, and means MA must be 9 centimeters. Now the question wants me to work out the size of the angle between EM and the base of the prism. So drawing a line EM, I'm forming an angle between this line and the base of our prism. You can see this is the angle I need to find. Now I've created a right angle triangle, so it's a bit clear that I have to use Pythagoras and/or trigonometry in this question. Because I'm asked to find this angle, I need to find length MB and length EB in order for me to work out the angle between EM and the base of the prism. So let's work out MB first. Looking at the triangle MAB, I have a right angle triangle with a length 9 centimeters and 15 centimeters, and I need to work out the length MB. I can spot Pythagoras. Pythagoras states to work out MB, it would be MB squared is equal to 9 squared add our 15 squared. This means MB is 306, so I know MB to one decimal place is 70.5 centimeters. Now I know MB, let's work out length EB. Well, EB can be found using this right angle triangle. Given I'm looking at a right angle triangle using lengths and angles, I know I have to use trigonometry. So let's identify the correct trig ratio. Well, given my angle is here, this would be the opposite length, and this is the adjacent. So the trig ratio that uses the opposite and the adjacent is tan. So to work out EB, it would be tan theta is equal to the opposite over adjacent. Substituting what I know, I have tan theta equals EB over 15. Rearranging to find EB, it's tan 35 multiplied by 15, so I know EB is 10.5. So now I know MB and I know EB, I can work out the angle in between the lengths EM and the base of the prism. We're going to have to use trigonometry again, and I'm going to use the length EB, which is the opposite, and the length MB, which is the adjacent. So the trig ratio which uses the opposite and adjacent is tan. Substituting what we know, well, the angle is what I need to find. I know the opposite is EB, I know the adjacent is MB. Substituting our lengths that we've just found, we know tan theta is equal to 10.5 over our 17.5. To find theta, I need to do 10 to the minus 1 of our 10.5 over our 17.5. Working this out, theta is 30.96375, so on and so forth. But because the question wants me to find it to one decimal place, this means theta is 31.0. Question 20 is the last question of our exam paper, and it states that CDEF is a quadrilateral. It states that the vector CD is given by the vector A, the vector DE is given by the vector B, and the vector FC is given by the vector A minus B. We're asked to express the vector FE in terms of A and or B, ensuring we give our answer in its simplest form. So just like before, label what you know. Let's label the information that was given by the examiner. Well, we know CD is vector A, which I've labelled here. We know D to E is vector B, which I've labelled here. And we know FC is vector A minus B, which I've labelled here. Now for me, to work out the vector FE, I'm going to sum the vector F to C, add the vector C to D, add the vector D to E. Well, we know F to C is given by A minus B, add the vector C to D is given by the vector A, and the vector D to E is given by the vector B. So therefore, simplifying our expression gives me the vector F to E to be 2A. The second part of this vectors question states that M is the midpoint of the line DE. X is the point on FM such that F to X, X to M is given by the ratio of n to 1. We know CXE is a straight line, and we're asked to work out the value of n. Now this is a hard vectors question, as it uses diagonals which intersect, but there is an easy way to work out the vector of one diagonal given the vector of another diagonal. So let's start by identifying what we know. Well, we know F to X is n, and X to M is 1. We also know we have the diagonal line C to E. Now looking at our vector F to X and X to N, it doesn't really help us. So let's look at the diagonal line CXE. CX can be multiplied by a scale multiplier to give CXE. So now I know the vector CX is equal to a value being multiplied by CE. We don't have to know what this value is, so I'm just going to call it lambda. Now I know to work out the vector C to E, it's simply A plus B. So the vector Cx is simply lambda multiplied by our vector Ce. Multiplying out, I have the vector Cx is lambda A plus lambda B. Now I don't need to know lambda, but we have something very important here, the coefficients. You'll notice the coefficients of A and B are the same. So if we can calculate the coefficients of A and B in terms of n and equate them, then we can solve for n. So let's identify our vector Cx and work out our coefficients of vector A and B. There's lots of different ways you can do this. I'm going to work out vector Cx by adding vector Cd to vector Dm to vector Mx. Substituting what I know, well, I know the vector CD is simply A. I know the vector D to M is a half B. And I know vector M to X would be 1 over n plus 1, the vector of M to F. Now, working this out, we have vector A plus a half B, and let's identify the vector MF. Well, to work out the vector M to F, you can see it's minus a half B, subtract the A, subtract our A, and subtract our minus B, which I've indicated here. Now from here, I'm simply going to simplify. Here's my A, my half B, my 1 over n plus 1, and simplifying this gives me minus 2a plus a half b. Multiplying out, now I have the vector Cx to be a plus 1 half b minus 2a over n plus 1 plus b over 2n plus 1. So multiplying my 1 over n plus 1 by the minus 2a gives me minus 2a over the n plus 1, and multiplying my 1 over the n plus 1 by a half b gives me b over 2n plus 1. Now remember, we need to identify my coefficients of a and my coefficients of b. So I'm going to bring all my a terms together and my b terms together. From here, I'm now going to factorize so I can find my coefficients. So taking out a gives me 1, and taking out a from here gives me minus 2 over n plus 1. This is my coefficient of my vector a. Taking out b from both terms, I have half plus 1 over 2 bracket n plus 1 b. This needs to be simplified a little bit more. So I'm going to make both terms have the same denominator and write it as a single fraction. Rewriting 1 to be n plus 1 over n plus 1, and rewriting a half to be n plus 1 over 2 bracket n plus 1. Now I have the same denominator, I can simplify further. N plus 1 subtract our 2 over our n plus 1, and here, making the same denominator, I have n plus 1 over our 2 bracket n plus 1. Simplifying further, now I can identify my coefficient of a to be n minus 1 over n plus 1, and my coefficient of b to be n plus 2 over 2n plus 2. Remember, we aim to get the coefficients of a to equal the coefficients of b. That was the purpose, so we can find our value n. Equating our coefficients, this means n minus 1 over n plus 1 equals n plus 2 over 2n plus 2. Cross multiplying gives us n minus 1 bracket 2n plus 2 is equal to n plus 1 plus n plus 2. And now I'm going to simply expand both brackets, giving me a quadratic on the left and a quadratic on the right. Simplifying gives me 2n squared minus the 2 on the left, and n squared plus 3n plus 2 on the right. Now, rearranging to make the quadratic equal 0, I have n squared minus 3n subtract 4 equals 0. Factorizing gives me n minus 4, n plus 1, therefore giving me the solution of n to be minus 1 and the solution of n to be 4. Given I cannot have a negative 1 as a value of n must be equal to 4. If you like this video, please give us a thumbs up. Leave your comments down below and subscribe to this channel so you'll be the first to know when we release our next videos.